This is question 1, part B and C of the extended response. And here we're required to find the equation of the tangent to the graph at this point. So this is worth 1 mark now. Finding a tangent a few years ago would be 3 or 4 marks. Now, because you have this as calculator, it's only worth 1 mark. So I've already defined my function up here that I'm going to be using, and we're going to use tangent line to work it out. So let's grab a tangent line, and the syntax for this one is the function, in this case f of x. See, we've defined it now, so we don't have to type it again. The variable, which is x, and the x value we're concerned with, which is 1. And that gives us the equation of the tangent, which we can write over here. So our equation for our tangent, we can write y tangent equals negative 9x on 5 plus 13 on 5. Now, looking at that diagram from before, we want the coordinates of Q and S. We can see that Q is the x-intercept, which means we make y equals 0. And looking up here, we can see that to find the x-intercept, to make y equals 0, we get 0 equals negative 9x on 5 plus 13 on 5. Let's go for the CAS. Now, to solve that, because we're getting into the habit of defining functions, let's define our tangent. So we can go menu 1, 1, and we're going to define our tangent. Let's call it y. So y of x equals this stuff up here. We've just stored our tangent. So we can solve for the x-intercept by making y equals 0. Let's use the solve function to do that. So we're going to solve y of x equals 0, and we're interested in x. That gives us 13 on 9. So the point Q, the coordinates of that are 13 on 9. So we can say, we can write it as a coordinate. We have 13 on 9, and the y value is, of course, 0, because it's an x-intercept. Same sort of thing for S. To find the y-intercept, we make x equals 0. Well, if we make x equals 0, we can read that off there. We're going to get y equals 13 on 5. Writing that as a coordinate, we get 0, 13 on 5. And those two are our answers. Now we need to find the distance PS. So there's the point P. We need the distance between P and S, which is up here. And we've got a particular form for our answer that's required. That'll come out in the wash. So you need to know your distance between 2 points formula, which is not on the Maths Methods exam formula sheet. So either have it in your bound reference or memorize it, because it pops up a lot. That formula is D equals the square root of the quantity y2 minus y1 squared plus x2 minus x1 squared. Let's have some fun and label these. So that's x1, y1, that's x2, y2. Doesn't matter, you could do them the other way. You could do x2, y2, x1, y1. And let's substitute those in. So at this point, you would probably just punch it into your CAS, but substitute just to show that you know what you're talking about. That's squared, and x2 is 0 minus 1, all squared, and it's the square root of that quantity. Rightio, what does our CAS say? So we want the square root of, where's it hiding? There it is. We want the square root of 13 on 5 over 5 minus 4 on 5. And the more you can do in your head, the quicker it is to type it, because you can type less. Plus, well, it's going to be 1 squared, which is 1. And we get a root 106 on 5. We get the square root of 106 over 5. Now, check your question. Check if there are units. There aren't in this case. But, I mean, it's a distance, so show you know what you're talking about. Write units. So that way, when you write your answer, you're saying, I understand it's a distance. I've got B and C as positive integers. And you're just ticking all the boxes there. You're showing what you know.